Very good people, welcome to JJ Tech Tutoring. In today's video, I'll be taking you through steady state error under controls and systems, right? So in this chapter, our interest is in the difference between the input and the output of the feedback control system. So after the steady state has been reached, then we need to then have the difference between the input and the output, right? So our discussion is limited to stable systems where the natural response approaches 0, right? As the time is approaching infinity, right? So unstable systems represents the loss of control in the steady states and are not acceptable for use at all, right? So it is possible to wrongly apply the expression derived, right, in this chapter to an unstable system, right? So engineers should know and should always check the for stability while performing any steady state error analysis and design. So without the waste of time, let us then get into the solving part, right? So before we can then talk about this, we have to understand that the final value theorem, or the formula that each and everyone should be familiar with, is this one that is called a final value theorem. You all have to be familiar with this equation, right? As you can see, this is basically a small letter f into infinity is equals to lim s approaches 0 as f of s, right? Now, when steady state error is in terms of ts, then you have to understand that let me then do a block diagram for you. That is having t is to s. Of course, here is our output. Of course, here is our input. That is r of s, right? So the steady state error is equals to the difference between input and output, right? So what is our output? Our output is equals to ts multiplied by input, right? So when we take this one into our output, what will be the final? So it will be ts multiplied by rs, right? Then we are having r of s minus ts rs. Then from there we're going to factor out our rs, so it will be 1 minus t of s. So that means our steady state error is equal to that, right? Our steady state error is equal to that. But remember, I spoke about the final I spoke about this the final value, right? So that means now we are going to substitute this there. So we are going to say, because you remember I spoke about a small letter f is equals to limit s approaches 0 as f of the Laplace, right? So we then have to understand that when we are dealing with this steady state error, then we will have something like this. S, then this one is what? Is this one. So R S 1 minus T S. That's it, right? So that is the formula that is derived when we are using we're doing steady state error in terms of TS, right? In terms of TS. Now we can move further with equations, right? So we can still solve the question, right? So question number 1 is find the steady state error for the system below, given Ts is equals to 5 over s squared plus 7s plus 10, right? For ut, right? For ut. So that means that is our unit step function. This is our unit step function when the input is unit step function. So for ut input, right? So what is our input? So first thing first, we can then draw the diagram, the block diagram. So this is our output, this is our input, which is said is our unit step function. Then our ts is 5 over s squared plus 7s plus 10, right? Then what is our rs? Our rs is equals to 1 over s, because of what? The Laplace transform of unit step function is 1 over s, right? So what is the formula? The formula that we derived is saying e is to infinity lim s approaches 0 s rs open bracket 1 minus ts. Very clear, very clear, right? So we have to understand first step, we have to then say s multiplied by rs, right? Those will be s multiplied by 1 over s, so that will give us 1. So now we're talking about these two, right? Now secondly, we have to then 1 minus ts. What will that give us? So 1 minus 5 over s squared plus 7s plus 10, right? Now we are dealing with what? 1 minus t of s is equals to 1 minus 5 over s squared plus 7s plus 10. Then we are going to use what? The fraction rule, right? So how many times does this goes here? It goes this one. So it's going to be s 7s plus 10. How many times does go come here? It goes 1. That means then minus 5, right? So the 1 minus t of s is equals to s squared plus 7s plus 5 divided by s squared plus 7s plus 10, right? Then from there, we can then take it back here into the ts, right? So we can then have our final answer as e infinity is equals to lim s approaches 0. Then we're going to put 1 here of rs and s, that those are multiplied. And from there, we'll then have our 5, our s squared plus 7s plus 5 divided by s squared plus 7s plus 10, right? So since they're saying lim s approaches 0, then we're going to put 0 here, put 0 here, 0 here, 0 here. We're left with 5 over 10, which is 1 over 2, which is ultimately 0.5. So this is our steady state error. This is our steady state error, right? Now we have to then go to a part whereby a steady state error is in terms of g, right? Of g of s, right? So we can then draw the block diagram where here we have e s and then summing point and then r of s and then c of s, right? So there is feedback here, so it can be positive and negative or however way, right? Now we're always interested in the difference between input and output, so that is going to be our main start. So rs minus cs, this is the first part. So what is your cs? Your cs is equals to gs multiplied by es in this point. That is the difference between in terms of gs and in terms of ts. So that is the only difference, right? Now we're going to say e of s is equals to r of s minus c of s, and from there we are going to substitute where on the c of s, which is gs e s, right? And then we understand that we're going to take this in the left hand side. It's going to become plus g of s e of s is equals to r s, right? Then from there we're going to factor out e, 1 plus g of s is equals to r s. So when it's equals to rs, so when we're looking for steady state error, then of course it's gonna be 1 plus g of s. So this is the formula in terms of g of s. So this is basically the formula in terms of g of s, right? Now say you're given equation, like this. We have to solve this in terms of g. 120 s plus 2 divided by s plus 3 s plus 4. So basically this is g of s. So c of s, there comes the feedback line, plus minus rs es, of course, right? So what was the final answer of the steady state error in terms of gs? So this is what it was. Rs divided by what? 1 plus g of s. So this is the final answer because this is what we got in the deriving, and we know very well that the final value speaks about something like this, right? And then this is going to be replaced by e of s only, right? And then e of s in terms of g is 1 over, it's rs over 1 plus g of s. So which is why that side it's like this, because this s has always been there, right? Now let me then try to solve the question, right? So e is equals to lim s approaches 0, s rs over what? 1 plus g, right? So what is our, we're supposed to be given RSs, right? Our RS surely, maybe when you're given 5 unit step function, so it will be 5 over s, right? So it's gonna be, we're gonna solve it like this. So we are given 5 unit step function, so the Laplace transform of this will be 5 over s. Then when we are then taking it into our formula, since this is this 1 plus g of s, so we can just take this here, 5 over s over 1 plus gs, right? So this is how it is. So we have to take this to the real fight. We have to take this to the real equation that says E is equals to lim s0 s rs over 1 plus g. So we're gonna say s multiplied by 5 over s divided by 1 plus g s. So this and this will cancel. We'll be left with 5 over 1 plus g s, right? Right, so don't mind my small letter g here. So then from there we have to substitute that equation that is given here on the g of s. So it's going to be 5 over 1 plus, on the g of s we put the equation which is 120 s plus 2 over s plus 3 s plus 4, right? So we have to then substitute where there is s by 0, and from there it will be 5 over 1 plus, and we have to then do the calculations of this 120, 0, and 0, 0. So this will give us approximately 20, right? So it will be 5 over 21, and that will be it. That will be it. So